Hi guys and girls, I'm Jacek Głodek and I'm a Scala programmer. I have a consulting firm called Iterators, and I have some experience programming Scala, therefore. Today I'm going to talk about typing better. So, what's in it for you guys? First of all, I want you to get some value out of this talk. So, this is not like really advanced talk. I'm not going to talk about free monads and stuff. This is beginner and intermediate level, as was said in the abstract. I want you to know like maybe two things after this talk, which is recognizing the problems of statically typed systems and being able to solve them in a conscious way. So the problems need to be solved. Inside type systems, and I'm going to talk about this exactly. Okay. So the types. Types are labels that we put on the data. I don't know maybe how much of you guys know Scala and statically typed systems and So these are just you know this stuff. Types are just labels with the data. Type systems are rules that connect those labels that let validate different stuff and the rules of how we associate these labels with the data. So we have two types of of type systems, dynamic and static. Like this is a simplified view, but in dynamic systems, the rules about connecting the value and the labels, the types, are not enforced. And in static systems, they are enforced by the compiler, by type checker. So inside static system, during the compilation time, the type checker gives us feedback about how's the integrity of the system performing. Is it consistent, right? So using this and the functional approach, the type system lets us build and transform data in a predictable manner. So we said that type system lets us reason about the code better, right? Okay, so the point of this talk is this. Static type systems are enforcing type integrity at compilation time can give us feedback about the problems of our programs, and with function they let us build systems. And using Scala, for example, we can build statically typed systems that will give us lots of feedback and will be much more secure to use. But we must consciously choose to build type systems. And often people just use Scala, and they are from Java environment and everything, and they use normal like primitive stuff, primitive types a lot, and they are not really consciously building the typology, the type system, to make the system more secure and more and letting us reason about this code, right? So the talk is about what we usually don't do, what we should do, and what we can do inside type systems. Okay, so I'm going to talk about primitive types, especially the case when we use them too much. I'm talking about unmarshalling and the marshalling of the data. I'm talking about hidden effects that are not represented inside type systems. Monkey patching around type design problems. That's on the slide, right? So Let's start with. You know, we all know primitive types. They're basically what really simple types like string, int, double, float, etc. They really don't give us much of the security. They are not really maybe concrete, concise, because even the standards of the floating point values are like nobody read them probably. Somebody read the standard maybe. Yeah, like nobody. Nobody knows. Oh, we got one person who knows how they work and okay, who read the standard. So we often we want to build our type systems, right? And we often face this problem of modeling our data, our business object inside type systems. So we just want to model a user. So he has name, he has email, he has bio, he has some password hash, and these are strings basically, right? And this poses a lot of problems for us because we then have problems with string basically can be empty. So this is a valid user, right? We define the type that consists of 4 strings, and a user can be just a combination of 4 empty strings. And this is not enforced by type system. This is not safe, and this actually can happen when we get some data from the user and he just passes empty strings. He submits the form on the web, and we get everything empty. It passes because it's okay, no exception is reason, and so on. What about if we try to, another problem, if we don't know, if we don't have a good type system, we can have a problem of changing the order of the parameters when we call a constructor of the type. Then no error is reason, right? It just is completely useless, and we have bug here. So type systems, first of all, we can use the dependent types, right? So we can just build a username. He has a name, which is a name. It actually has some structures. The structure, name have structure, email has structure, it has format. We can have bio, which also is validated by the type system. We have password hash, can be string. Of course, password hash can also be type checked. For example, we can check the length of the password hash and so on. So basically, these are the value dependent types. This is how we call them. And we can build, the point is to build the system, like we try to define user. The point is to create the system from the small building blocks that are already safe and that are typed. They are not just primitive types. We actually build small types that build bigger, bigger objects. Okay. So this is easy. We can create some kind of a case class in Scala specifically. We can validate these types, and every time the constructors run, we can get an error. So name cannot be an empty string, so we can just validate that it's longer string. We build the name. Type as from the building block, which is the string, and we add some logic to it. We add some specificity, which is we want the length to be proper. For example, email has a format, so we can check the regex, it with the regex, and so on. So we have types that are better we can't now build a user with empty name and empty emails and so on. Okay. So this kind of thing always requires some syntactic sugar. Like we cannot always, if we build email and we want to print it, of course there will be problems with, because it's type, it's not a string, it will call this toString method, and stuff will look maybe badly, maybe it's better. But we need to build not only the type declaration and validations, we also need to build some or use some library that gives us some syntactic sugar that makes the usage of the type much easier. Yeah. Okay. So the second thing is unmarshalling. As we got our types and now we get to we need to get them working inside of our system. The unmarshalling is like we can call it here the process of transforming some data into internal representation. So we get some data from the users, from the form, in the web. It gets to our server. It's just, let's say, JSON document, and we need to parse it and transform it into our user type, right? So this transformation we'll call unmarshalling. Okay, so unmarshalling can work on different levels of abstractions. Often we have, like, what we get from the server or our web framework is, for example, HTTP request. Then we can put the data from the HTTP request into some data transfer object, and this is which also can be typed, and then we can turn it into business object that is actually from our business domain that we modeled with our types, right? So we can there can be chaining of the marshalling stuff. I'm sorry. I'm sorry. This is 1 moment. It's not like ordered, and I ordered it. So that's good. Okay, so first of all, when we unmarshal stuff, and for example, we get this kind of problems when we try to just get some email from our HTTP request and create our type, and we get into problems like this just raises exception. So that's pretty bad. We don't expect, as we are functional programmers, we don't expect the functions to raise exceptions. We want them to return value always. So this is much more predictable when it returns value instead of raising exception. The second thing is that we need to embrace the idea that the user can provide us with the bad input. So it won't just rise like internal server error every time somebody posts anything. It shouldn't. It shouldn't always also. We shouldn't we should have some reasonable error messages, not just get some input from the user and the server would just die in this moment, right? Okay. So unmarshalling must embrace bad input. It must the bad input is not exceptional state. Often there will be bad input, and in bigger system we need to embrace that this happens even if we got our AngularJS validations on the front end. We also need to validate things on the API, and it shouldn't kill the server, right? So it's normal situation, and we need to treat errors like we're just validating things. Okay. Okay. This doesn't work. Okay. So we got our error here. We got our dependent type, and it raises exception. What we can do to wrap our exception raising type into a value, we can use types like try, which will just instead of a illegal argument exception, it will return a value that is actually failure, and just with the data that there was an internal illegal argument exception. So this is normal value. We treat it like a value. We should model our controllers, our business logic, using this type to process the request. Okay, so we could just write email user input, right? It would raise exception. The server would just fail. It would return 500 to the web page, to the web browser, and it would be okay. but we want to have statically typed systems. We want them to be like we want to reason about the code. We want to know that if we subscribe someone to the newsletter, we want to know what's the result of this function. We want to know that it's always HTTP response. It's not just an exception that will propagate through the stack of the program. So what we do here is we wrap our unmarshalling, which is putting the user input into our dependent type. I will use maybe mouse here. There's no mouse. Okay, so we put our dependent type inside this special try type, so we can now just match if it's failure, if it's okay. If it's an actual email, we can then just process it safely because it's our validated business object. We know that it matches the regex. It's all cool. It's a normal email, or we can handle the exception, and we can return explicitly the bad request information that the email was wrong. Right. Also, this of course can be chained and embedded in one marshalling inside another, and this function actually handles the cases when this unmarshalling can fail. And normally we would just put the exception to propagate and raise 500 error. Okay, so now we have here we can use our email link services with normal object that we know it's validated, it's type safe, so it's cool. And we should do that, and we often don't do that. We just let it fail without type checking, right? So it just fails much more often, and it's harder to reason about the code. Okay, so this embracing errors when unmarshalling means that we don't have to use try, catch, finally blocks, which are not always easy to reason about because they are not values. We cannot use them in functional. Use them with functional approach. We cannot map over this try, catch, finally blocks and so on. These are not values. These are just blocks, and we want to program using function. we handle error as, and validation as normal values, and we embrace it, that they happen. And we handle them all. Okay. So we use dependent types to make validations. We don't use the if. Also, the important stuff is this email dependent type is already validated, right? It's good data. We don't put our input inside an object and then ask the object if it's actually valid. We know that it's valid because it is type safe, right? So we don't have to ask anything. We know it's okay. We mapped it. We used the functional decomposition to know that in this one case, where the email is in the right format, it's a valid email. Okay. So we don't want the exception to propagate, and we want the return values to be values. So this is often omitted, and I encourage you to do that. Again. Okay, so one big problem that I see when people program Scala and type systems is that once they have some object, they tend to refactor the code around it. Yeah, I mean, like basically refactor, right? So we have a nice code. We probably have some validations there, and we just need to save this thing into database, right? So that's a problem, because when we create a new user, we want somebody signs up. He doesn't have an ID, so the validation won't pass because it's just we need long value and we have none. So we put an option around it. We put option around email because it's maybe we need to do some email verification, so we don't state it as it exists, and it's really bad. We save so many lines of code, right? We just added option, but the rest of the system looks now really bad. Like every code style tips will tell you that in Scala you shouldn't get on the option. Like this is violating of our functional type safety thing, right? This is our new null pointer exception. We can download something from the database. We will have member. It will have an ID. We try to get it. It's empty. So everything fails. And it fails on the runtime, not on the compile times, right? So okay, we can do better. We can have two classes, two types, right? So we can have unsaved user. We can have also user, which is a saved user. And as you see, this is like complete type. We don't have to use options here. Especially the problem with the user is that probably our business rules state that user must have an ID. So when we create new user, we don't have the ID. Now we have two types, which is unsaved user and saved user. During the creating of the user, when we have some sequence in our database, the returning row, when we insert it into the table, we will get, for example, the ID inside the row, and we can just fill the proper user. We get the unsaved user, and we get back a user. So that's great. We don't have to patch around this system, type system, right? We don't have to introduce options which make our rest of our code perform unpredictably, because every time we think of a user, we need to think if there's an option there, we need to think that the value is optional. And we should, like in this case, when we get member ID get, and if it's an option, we should explicitly map it into a case where when there is an ID and there is no ID every time we use it, right? And that's not the case if the business rules state that the user must have ID. Okay, so we should keep the types concrete. We should use if business rules state something, we should model it inside type system. We shouldn't refactor around it. And this sometimes can be look bad when we see the amount of code we're generating. But we should learn to do it better, right? We should find libraries or write our own libraries that will add maybe macros that will add some syntactical sugar in order to make this look pretty, not ugly. Okay, so let's keep this type system concrete, right? Another thing is the problem of hidden effects. We often see this kind of method in Scala, like get user, we pass just user ID, and this is our declaration, right? We should get a user option. Okay, so there may be this user in the system, or he may be not found or not existent, right? So the problem is that when we travel down the rabbit hole of this function definition, we now see that it tries to fetch. It gets the user, right? It must be fast because we're doing really like heavy throughput systems. So it tries to get the user from the cache. If he's not in the cache, it tries to reload it from the database. And there's like a geocoding data that we may want, and it will just try to fetch it from the Google, so we can have all the great data about the user, and it's hidden behind the name, right? This stuff we can reason about it. It has user. Either user exists in the database, or he doesn't, right? And it's simple. This one is if this is the real implementation of the function, the option can return false or can return none, even if the user exists. So we now lost a lot of context around lots of understanding about this function. So we get none because the Google servers were not available, right? And it's hidden inside our declaration of the function. The name is just wrong, right? It hides facts. Sorry, yeah, exactly. So doing functional programming, we should control the number of side effects, and it will help us reason about the code, okay? So we should state return types explicitly to know what we can expect from the function, and we should name the functions according to their actual, maybe not implementation, but actual effects that it has, and the things that the function depends on. Okay. Another thing is, if we don't do this, if we don't state the return types explicitly, we get into a problem where the type inference mechanism can fail, right? So we create some option here. Actually, it's not option. It's a subtype sum of int. And when we try to use it later, the function will return actually sum, not option. So we can't process it later like it was an option, right? We will get an errors, and this is not obvious. And if we just state the return type that it is actually an option, then everything will be okay. So, and it will be much easier to reason about the code. Okay. So here we're gonna get another function, get quota. Let's say this is like a amount of disk space our users has, right? So we just filter. This is like maybe slick table inside Scala, our database ORM. So we just find the quota by user ID and we return first option. So this probably returns option of quota. Great. And the problem is when the functions get really long and we try to return lots of stuff, this gets unreadable automatically, right? I don't know what this returns. This returns some tuple with lots of sequence of tuples with lots of things going on, and I'm not sure if the type inference was working okay. So this can be like really bad. So sometimes return values are obvious, like in the first case there, and sometimes they're just we just can't reason about them. They're just sequence of string, 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 and a tuple of string and double, and product with serializable. Like this doesn't make much sense. So we can again use type system and define explicitly what is the return type of the function, what kind of tuples does it return. We can say it's sequence of member informations, quota informations, other stuff accordingly, right? So this is like type safe. We can also reason about it. It's really readable. It's cool. And even though we have IDEs, this is really not readable inside IDE. So also using type system make further programming even easier because we have more types. We can the IDE has an easier job to inference them in real time for you to code. Okay, so there is again the problem that we saw a moment ago, the tuples, which are really bad. Like you can model things in using tuples, or you can use our type system. They're rarely explicitly typed, so we can make lots of bugs. The IDE won't help us. The error messages will be really bad, and the code that we need to we use to process tuples, if they're more complicated tuples, it's really not it's not obvious what this kind of stuff does. Also, if we create tuples, for example, in two places, that will be like two lists of tuples that we create in two places and we concatenate them. There is a possibility that we just swap something and the ordering is not right, and it's really bad. Okay, so and one of the last things is that we have we often do shallow functional decomposition. We use this mathematical concepts and functional programming concepts, low-level functions, too early inside our business logic, so it gets brittle really fast. So this is kind of readable, right? We just get some form and we get the user and we try to prepare the form for the user, and later it just gets really obfuscated by the functional programming logic. Right, and we could just use another function, more functions. We could prepare them, like decompose them further. So we could have here only just get me the form tag, and fill its body with our form for this user. Right, and this would be like 2 lines of code. And here, all the logic and readability is gone. And probably the functions that we would use later on, this get me a form tag and get me and fill the body of the form tag with the for this user. They would be much simpler, and we could just there would be explicitly said what this function, this combination of mathematical and functional operators do, and it's not obvious always, right? Okay. So the simple pattern I propose here is we should do top-down functional decompositions of the elements of our system. We must handle the garbage in, garbage out stuff. So we need to unmarshal things consciously, knowing that there should be no exception. The exceptions shouldn't be the return value of the function, right? So it shouldn't be that the exception is popping out somewhere and it just propagates over the stack. This shouldn't be the case because it makes reasoning about the code worse. And we should keep control of the side effects. Again, so it's more we can reason about it. When we create definition of types, we shouldn't go with top-down approach. We shouldn't say that user is 4 strings. User is not 4 strings. User data consists of email, which is an email, consists of name, that is a name, and so on. It all has, it should be built bottom up. So we build, first of all, we build a type which is name, email, URLs, and so on. And then from these little building blocks, we build more complex things further, right? So this lets us keeping the business rules concrete, right? So we can model our systems, our requirements that our clients give us inside a type domain, right? They are typed safely. Okay, in reality, there's of course it's not like types are all roses, right? When we don't use types, like in Ruby, our productivity can be really high, right? When we use just primitive types, it sucks. And again, typing helps us having a productivity, and also gives us another good things like reasoning about the code. So it's really fine. The safety of the code is really it's better than not typed system because we can reason about it. We know that if we do our no exception things propagating through the stack, we know what we can expect of different functions. Also, readability is maybe the problem because you can, if you're a type magician, and you use really lots of types, you can program really beautiful DSLs. I think even better than in Ruby and stuff. But you can go into a math stuff, and I mean math inside business logic stuff, which will make your code completely brittle and unusable. Also, when we think of maintenance of the system, when we need to hire somebody or let our colleague take our system that we designed and he has to maintain it can be really hard for him. And so it would be more like the slower boundary here. Okay, so if you want to know, this was like simple stuff. If you want to know more, I really encourage you to write this type statically typed systems and concrete systems. And I think it would be great if you learned about Scala Z validations. They're really great DSL for validations, and they're composable. You can see tag types. they remove lots of problems with our dependent types. That means that when we need some basically syntactical sugar for our dependent types, it's just we can use tag types and they are really great. Also, when we were talking about unmarshalling, and I told you that you should wrap your function inside a try or this kind of stuff. If you're using futures, this can be just future, but it should you should embrace these errors. And John Pretty, who will have his presentation tomorrow, he created a great library for doing that. It just automatically wraps things for you, and you can just state in which type it wraps it around. Also, there's a great GitHub page created by Konrad Malawski. It's called Types of Types, and there are lots of examples of different types, and it's great. Go ahead and read it. Okay, so thanks. I'm Jacek Głodek, and if you have any questions, or we have like 1 minute or so.
I haven't done much Scala, so maybe it's a good question. But the validation you've shown with the types hasn't been required. I tried, and it only happens at runtime. So even if I...
Yes, of course, because it's like when... Yes, it happens in runtime.
Yeah, but then what? It doesn't...
Because it must validate... It is, actually. Because you are providing user input, so user input usually happens after you run the server, not when you compile it. So this validation will run then, right?
Well, type checking normally depends at compilation time, right?
Yeah, but you explicitly created a type that handles this situation, and it's modeled, right?
It would be the same if you did in the constructor, just a check.
This is basically a check in a constructor. The require thing is a function that runs in a constructor of the case class. So it actually runs run in runtime, right? But the idea is that this little thing there, this require thing, lets you know that nobody will ever construct this object with bad values inside, right? So next, when you get this object from other function as a parameter, you know that it actually is thing that has only like it is real email. It passed the regex stuff. It's not empty. You can reason about it like this. So you know it's email. It's not like nobody could construct this object if it was constructed with bad data, right? So the idea is to validate things using this. So it joins the statically type compile time checking and validations on runtime, and then reasoning about the validated objects later. So that's like thing. Any questions more?
You suggested to make effects visible in the return types of your function settings. Option, for example, or try. On the other hand, you also kind of suggested that at the argument level, the options could be dangerous and split it into two constructors, the user and the saved user. But are there situations where you can combine both?
I mean, I would need to see maybe an example. Maybe I go back.
So it was, on the one hand, you said, okay, make your effects visible in the return type, okay, by wrapping something into a try or an option, okay?
Yeah, if that's actually you can return normal type if it's short, right?
It's no problem for me. Yeah. But before then, you were talking about this user with an optional ID, and you said, okay, that's maybe not such a good idea.
Yeah, because it was ever. So we changed here we changed the whole type to use options in places where it shouldn't be an option, and then in the rest of the system we have to use some really obscure stuff. And it was my point. Like this get thing is not pretty safe. It will raise an exception actually, so it's not that safe. It's okay to use optional, of course, arguments, right?
But that's what I was actually thinking. If you can do it, well, it's not the only way to treat it by doing the get. That's what I wanted to suggest, right?
Yeah, and here maybe is the place where these are optional arguments for some function inside Windows API or stuff. The point is that it's really like where do I put this dimension? Here. Yeah, this is like obscure, and it could be better, right? So if this was actually maybe types, maybe some better function. This is like really bad.
What about performance? So
Exactly.
Even though integer and string looks like object, integer double looks like object in Scala. Scala compiler can compile it in real primitive types on level of JVM, which can be further optimized by just-in-time compiler and so on. And what about performance of the cabbage collector? I think these short-lived objects will cause that the young generation collection will pose more often, and how it will impact on
Yeah, so I wanted to draw another one with the performance using. First of all, the compiler performance can lower if you use certain types of types. We can have really a long compilation, and also if you use case classes everywhere and we don't model it in a proper way, they will have runtime. They will slow things down, right? But you get safety. Maybe, yeah. I don't know. If that's the answer, it will certainly be slower. But if you there's a way to explicitly state something inside the case class that will make it like that make compiler think it's just a value. It probably extends any val and it will treat it like a value inside an object. So just one value primitive type inside the compiler. But the type checker will check it. So it's kind of better. Yeah.
Unfortunately, we've run out of time.
Yeah.
So
Great, thanks.
we'll end.